Okay, in this question we were told that locomotive provides a constant power of 2 megawatt. Now we know that power is F times V. So if the power is constant, that means when the train is traveling at very low speed, the locomotive can provide a very large force. But as the train becomes faster and faster, because the power is constant, right? So as the velocity becomes larger and larger, the force provided by the locomotive will become smaller and smaller. And that's why there's a maximum speed at which the train can travel. Because the question said that the train experiences a constant resistive force. So when the train is starting from very low speed, the force provided by the locomotive is very large. So you have a forward net force and the train can pick up speed. But as the train becomes faster and faster, the force that's provided by the locomotive will become smaller and smaller, right? Because of this here. And once the train is going so fast that the force provided by the locomotive only matches the resistive force, then you get net force to be 0, and that's when the train stops accelerating. It has reached its maximum speed. So we were told that the maximum speed is 40 meters per second, so we can use P is equals to Fv to calculate the force provided by the locomotive when it's traveling at 40 meters per second. So we are going to put in 2 megawatt for the power, and we are trying to solve for the force. The maximum speed is 40. So from here, we obtain the force to be 50 kilonewton. So that means when the train is traveling at this speed, the locomotive is providing a propelling force, a forward force of 50 kilonewton. And that means the constant resistive force experienced by the train is also 50 kilonewton. Okay, the question asks us to calculate the acceleration when it's going at a lower speed, 10 meters per second, before it has reached its maximum speed. So the train is still going to experience the constant resistive force of 50 kilonewton. But at a lower speed, we know that the propelling force is going to be larger than 50 kilonewtons. So what exactly is that force? We can calculate again using power equals to F times V. Power is constant at 2 megawatt. And the speed of the train is now at 10 meters per second. So we obtain the propelling force to be 200 kilonewton. So there's a resistive force, 50 kilonewtons, and a propelling force, 200 kilonewton. So there's a net force that's in the rightward direction, and that's why the train is going to accelerate forward. So now we are going to calculate this acceleration. Of course, net force is 200 minus 50, which is 150 kilonewtons. So if you want to calculate the acceleration, you take this net force divided by the mass of the train. But this question only wants the net force apparently. Yep, so that's the answer. Okay, ta-ta!